Good to have you here.
Okay. Yeah. Good morning, hour, and good evening to you all
Good.
of you.
So nice to do a part two, huh?
I really appreciate you taking time and joining us, and start the process. Okay.
What do you have that's new for us this time? Last time we spoke about dark matter, dark energy. We just touched upon parallel universes, and we just touched upon alien life. But I've got so many questions, and everyone only wants to know about alien life and parallel universes, and that's really their area of interest. So I was wondering, you see, there's a lot on the internet, right? I mean, if you Google it, you have tons of things, but then they're not really backed by evidence, proper scientific evidence.
Right.
I was just wondering, what is it? I know that NASA is interested right now in it because, as you mentioned the last time. So, what is it that NASA has discovered so far? And what is it that they're looking for, or what is it that they found? Can you tell us from the scientific perspective, meaning with research? Like, what do we have with research as of now?
Okay. So let's go back to our dark matter, dark energy, because that is the field right now which is very raw. There hasn't been much information available on that. So NASA is designing a spacecraft right now, and I'm also working part of it on it. And it's a mission called Euclid, and that is going to go out in the space, and that will detect the telltale of the dark matter and dark energy. So, because there is a lot of interest, as you know, the dark matter is the one that is responsible, to hold all the galaxies together. Without the dark matter, all the galaxy, which is rotating at such a high speed, will, fall apart and tear apart. So it is believed that dark matter is the one that is holding all the galaxies together.
Can you tell us a little, before you go any further, can you tell us the difference? Because I know you cannot see dark matter and you cannot see dark energy. So how do you differentiate between the two without really having seen them? Or without really, neither one has been, neither one is tangible as of now.
Right. It is the, effect that, you see it. You don't physically see it, because dark matter and dark energy, they don't absorb any light, they don't reflect, they don't emit anything. So you cannot detect it. So the difference between the two is the dark matter is believed to be, sort of particles versus the dark energy, which is, the waves. So the particles of what they are trying to do is find out if we can get those particles detected. So right now in Switzerland, there is a collider, in which what they are doing is they are bombarding a hydrogen atom with a very high energy radiation to break apart the atom. And they believe that once they do that, they can detect the electrons and protons very easily. That we have the technology for a long time, but they believe that there will be some particles that will come out, which is believed to be the dark matter. So that's the experiment right now that is going on. So that's how we're going to detect it. Yeah.
Oh, so dark matter, when you say dark matter, it's not just dark matter that's out there in space. They are trying to find a part of that dark matter in the matter that we have right now on Earth, right?
So what we are trying to do is, we are trying to find out that whether the atom contains that dark matter in terms of some particles that we have not discovered yet. And again, the dark matter is the one that is holding all the galaxies together, because all the galaxies are rotating at a very, very high speed. Just imagine a ball, on a string that you are rotating in the space. Once you rotate at higher and higher and higher speed, eventually the ball will break and fall apart, So that's what's exactly is happening. Unless you have a very strong string or something else that is holding the ball, it will, just go away. So that's the same concept in the, space that is happening. And that's the dark matter that's holding, all those things together.
So what is the role of dark energy then?
Okay. So dark energy is on the totally different aspect. So what's happening is the universe is expanding. If you can imagine a balloon that you keep on putting air inside and it keeps on getting bigger and bigger. That's what is exactly happening to the universe right now. It's expanding. So it's expanding at a very fast rate. And with that expansion, there is nothing that we know of that is causing that. Because galaxies, they have their own gravity, which is actually attracting all those, galaxies and holding them together. Whereas the expansion is the opposite of the gravity. It is really repulsing. So we believe that there is an energy, which is the dark energy, which is the repulsive force that is causing this expansion of the universe.
So do you see a boundary to that dark energy?
Right now, as we know, the universe is roughly about 13.5 billion years of radius, light years of the radius, because that's how far we have detected the light. We don't know how far beyond that it goes. Nobody knows yet. Right. So as we develop more and more technology, maybe we'll find that, okay, now instead of 13 and a half, maybe it is 20 billion, 25 billion. But it could be, keep on going on up to, infinite, so nobody knows until, we keep on detecting it.
Right. So infinity is something that, so scripturally, or even our understanding of the spiritual understanding of space or dark energy, what you call dark energy, I don't know if it would fit into that, but, it's infinity. You're talking about this energy that is infinite, which is the cause of everything that exists in this universe. It cannot be seen. So this is how Gurudev, Shri Ravi Shankar explains it. He says it cannot be seen, it cannot be felt, it cannot be experienced, but you can only be it. You cannot experience it, but you can only be it.
You can see the effect of it, right? Exactly.
Yeah, as in like, no, you can, yeah. So everything that you see, everything that is tangible springs from there. That is the source of energy of all of creation. So would you say that, so that is, I've just very broadly defined it. And that energy that I'm talking about, that is infinite, that doesn't end anywhere, because that is the source of everything, the creation of everything. Do you think at some point dark energy could turn out to be that?
So basically right now, as we know, dark energy, it is the one that is responsible for, expansion of the universe without galaxies colliding with each other. So that is what we have detected, because we know the universe is expanding because we are measuring the galaxies today, and maybe few days later, we see that it is further apart. So that we know. So that's why, this dark energy came into the picture. So scientists say, what's going on? What's happening? There's no other force in the space that is causing the expansion. So something must be causing it. So they term that something as a dark energy right now. Okay. And so this Euclid mission is going to, going to the space, and it has a very high technology detectors. So it's going to detect the infrared radiations and all that, and see if they can, detect something unusual in terms of energy, so they can pinpoint that, okay, yes, we found the dark energy. So that's what is going. So we don't know right now, what it is exactly. All we know is conceptual. It's like, if I have to give you an analogy, like 200 years ago, when the magnet was there, people knew that when you put the magnet by the iron, it attracts it. But they didn't see any force, or they didn't know where it came from, that force. They knew there was a force that was attracting. But then later on, the scientists put the, little iron filings around it, and they could see the line of magnetic, force. So that's how they detect. So same concept we are going. Right now, we know there's a force or energy, but we don't know, what it is and how it is. So we are going to someday, definitely detect it,
So we don't know the nature of that.
Exactly. It's a completely different energy that ever exists anywhere, It's a total different type of energy, So, but it's pretty massive, pretty strong.
Right. Coming to matter, since we're talking about it, matter, that the way we understand it is five elements. We don't know beyond five elements. Am I right?
Correct.
Yeah. So is science looking at the existence of more elements? Maybe not as tangible and gross as we see it and we know it, maybe a little more subtle, but are they looking at the possibility of the existence of more elements than beyond the five elements?
Scientists definitely believe that, the elements that we have discovered on Earth, and as we know of all, you know, is not everything that exists in the universe. There are other universes or maybe other galaxies or something on which more exotic, you know, uh, elements exist. So we believe that, even in our own galaxy, there may be existing some, objects that may have exotic, materials besides these five elements, So, so that mission is going to go and collect some data from one of the asteroid, which is orbiting the sun between Mars and Jupiter. It's called Psyche. And it is very unique asteroid because most of the planets and everything has a very similar structure. It's made up of either ice or rocks or a combination of that. Whereas this particular one has a nickel and iron core. So that's of particular interest to see why is it so different and is there anything more exotic on it. So yeah, scientists are always intrigued that there is something more than what we see and have over here. Even on Earth, there are still some missing elements we have not discovered. There's always a search going on, and they know that there has to be something more than what we see it, and what we perceive right now on the Earth. So
so we believe that there are other subtle realms which are not necessarily physically far away. Physically, they could coexist, but they're more subtle. And maybe that's how we don't see them. Maybe it's a different frequency. Maybe they're different elements, you know. So is science interested in that? Are you looking into something like that? Other realms that coexist right now with it,
so
here, with like amongst us.
see, right now the main interest the scientists have is to explore our own universe because it is so huge and so big and there is so many unknowns. So the focus is on that. Now, as far as the other realms, scientists really are not very much focusing. The only thing I can see that it's definitely exists. Now, even if on the Earth, and I don't know how much this is true or it is, but people have experienced that some of the people who died, they come back. And,
Yeah.
you can talk, you can see them, but you cannot touch or feel them. And they come and they disappear. So to me, I think that is a different realm that they are appearing, which we don't have it. And right now, scientists and everybody says that is like a paranormal experience. That's how they are just classifying it. Besides that, they have no other clue, as to why and what is happening. Maybe you can say from the spiritual point of view, Sangeeta ji, you can explain and see what is your thought.
No, we know it like this as connected to this earth, connected to us. There
Mhm.
are other realms, seven higher and seven lower realms,
Right.
and we right now in this physical form we are here, but when this physical form drops, then we may exist on those other planes as well. And they're all connected to this earth, so they're not very far away. They're quite pretty interconnected with where we are right now. They call it Bullock right now over here.
Mhm.
um, yeah, and other than that also, but it's not limited to only this. There are so many worlds like ours, and then there are so many. It's not even limited to worlds, they're universes. like, like you say, like we spoke about parallel universes. And so we know that these parallel universes exist. And in these parallel universes, it's not that the universes exist, even you and I exist over there uh, simultaneously. It's not someone else like us.
Mm-hmm.
We ourselves exist in different places simultaneously.
Right. I can expand what you are saying from the scientific point of view a little bit.
Yeah,
You know,
yeah,
we talked about the quantum physics,
right.
right? The
Yeah,
quantum theory. Okay,
yeah,
so let me just briefly touch base on that. Okay,
yeah, yeah.
so the quantum, theory was invented sometimes in 1920s, by Niels Bohr. He was uh, like a Danish scientist, you know. And so what happened that the quantum field deals with a very, very small particles, atomic and subatomic, So the laws of physics that Newton invented in the 15th century, where the apple falls from the tree on the ground and it doesn't go up. And then when the body is in motion, it will continue until you put an external force and stop it, or you accelerate it. And the action and reaction, all those laws, that was applied, that is we call is a macroscopic world, which is the large, part of the world. Whereas the quantum physics deals with the microscopic, which is, subatomic particle. The laws of physics and Newton, when they tried to apply to it, it didn't work. They were totally wrong. And here is how an example. So what happened that the electrons and protons, they move around the nucleus of an atom, right? So
Right.
if you apply Newton's law to that, what will happen that all the electrons will bombard on the nucleus and it will self-destruct itself. However, it doesn't happen. We know that the electron, they go on forever, they don't self-destruct. So that's why, they say that there is something else, there are some other laws that can be applied to those quantum at the quantum level, which is, not the same as Newton's law, So when they, discovered that they are, not exactly, the laws are applied, they thought that those electrons are some kind of a waves and they move around. And then further research, what they did, there was another experiment that I want to like to describe. So they put two slits, like a rectangular openings, and then behind that they put some kind of a board with the sticky substance. And what they did was they fire a small balls, metal balls through that slit. So the two parallel slit, when the ball went through that, they went through and they went on the back and they form another slit parallel to that, with all the balls stuck to that. So that was at the macroscopic level.
Right.
Then what they did was they fired the electrons and photons through the very small slit again. And what you should expect is the same result as that whatever goes through the slit will form that image.
Right.
But in this case, it didn't happen. What happened that they formed 4 or 5 different images in the back, even though there was only 2 openings. So from there, the quantum theory came up, says that, a particle can exist simultaneously at 2 different places at the same time. And that's where the concept of parallel universe comes, that a simultaneous universe can exist just like our, universe, and can have something similar to what we have. So that's the concept that came from that quantum physics, of the parallel universe. So of course, right now, there is a research going on, but I think we are still at.
Sorry, how far has
Yeah.
that study gone?
Right now, it is a very preliminary stage, because there is no evidence right now that we have found, It's just on the theoretical basis. Everybody has a different theory. There was a scientist in Princeton University, he came up with a similar theory. He says that, yeah, there are parallel universes and there are exactly people like us exist over there, So he came up with that theory. So there are different theories being come up, and some theorists say that, there are parallel universes in which we exist in our past, as well as in other universes we exist as our future. So there are all kind of concepts being put, and yet there is no proof, because we haven't even explored our own universe, let alone the parallel universe. So Someday we will have
This,
some
this
evidence, but
would defy our idea of time, wouldn't it? Because
so
see, it's like time to us is one after the other. But if we're saying that we're right now, at this very time, we're existing parallelly in different places and different universes, but some are in the future and some are in the past. But we know that it's that future and the past is right now. So it means that the future, past, present, everything exists now in this moment.
exactly. However, just think the time, what is time? Time is something that travels, you know. So in
Huh.
other words, if I'm looking at a star, which is like, say, 100 light years away from here, so what I see on that star is what I see that was 100 years ago happening.
Oh, right.
So depending upon how far the parallel universe is, we are looking in a distant past. So
So it means so it's all relative. So when we talk in terms of time, it's relative, and for us, it is now. So if you're looking at a star which emitted light some so many million years ago, but for us it is now. So time
exactly.
then becomes relative. Time is it's not real. It's just relative.
Time is
It is
absolutely
just
not
a movement of object in space or light in space, or it's just the movement of something in space which we relate to, isn't it?
exactly. And there is more to it that Einstein came up with. That's why he calls it a space-time. He doesn't call it a time. He called it a space-time. So what it is that when the signal travels into the space, there are so many galaxies and some of them so massive, so it distorts the light, and it takes a little bit longer for the signal to come. So what we think is a time is not exactly what the time is. It all depends how it travels. So it can be longer than what we think.
Right. So it was probably obstructed and it took
Yeah,
curved
it's
and it
called
took,
distortion of the time in the space. It
yeah.
distorts the space, distorts the time. So really, time is nothing absolute. That you can put your
That's
finger.
amazing, something you told us, because our understanding of light is light moves in it moves like in
Straight
one
line.
line, right? But then if
Right.
light can bend, that's
Yes,
amazing, because
exactly.
then that just changes so much for us.
Yeah, I mean, a simple example, like if you put a pencil into the container with the water, and if you look at the light, you
True.
see where the pencil is at the junction of water and the air, it
Yeah,
bends,
it
right?
bends. It
So
bends.
so that's what
And
exactly
that's
it is.
so it doesn't really bend, it's just our perception.
It's a refraction.
Yeah.
So
Yeah.
that's what happens, that the light, it slows down, it refracts.
Hmm.
With the massive galaxy. Those galaxies are so massive. There are 100 times massive than ours. So there is a tremendous amount of gravitational force that bends the light. So, so that's why the time concept is completely, relative, as to how you look at it.
But as a scientist, it must be so different from you, because human beings have this massive ego where we think that this whole universe revolves only around us. It is bizarre to believe that such a huge creation exists, and we are still thinking, we're still wondering, is there life on other planets? I mean, is there other life beyond us? There's this whole huge creation. Of course, there is life other than us. There has to be. Just because we don't see it, we don't know it, doesn't mean it doesn't exist. No? Isn't it?
Yeah, scientists are 100% convinced now
Yeah.
that there is a life. In
Yeah.
fact, they have found so many planets. They are what they call is a habitable zone, just like what Earth is, the sun, the right distance, the right size, and things like that. So they have found many those. Now it is just a matter of getting some signals or getting some more technology developed so we can really, see what's happening over there, if there is a life. Now, there is another research that is going on parallel to that. See, until now, scientists believe that for the life to exist, there has to be the sun same as our size. There has to be an Earth pretty much similar to our size at the similar distance. So they were focusing on that, and they couldn't find anything in the space. So there are several scientists that thought that no, there has to be a different other things. So they were focusing on what is called a white dwarf. They are the smaller suns than ours. Okay. So with that white dwarf, the planets can be much closer to them for the life to exist, because the heat is very small amount compared to the heat of our sun. So that they made that research, they have discovered so many of them, and they have discovered the planets going around them. And now they have come up with a theory that those planets, they are very close. However, they can habit the life, because what's happening is one side of that planet is always facing the sun, the way it is rotating around the sun.
Right.
The other side is always dark. So there is a night perpetually on one side, and there is a day perpetually on the other side.
Right.
And of course, the temperature on the night side is like a minus 20 degrees, which is very cold temperature. Whereas on the sun side, it is like a very hot, 100 plus degree temperature. So then they came up with a theory that there is a zone called a twilight zone between the two. That's where the life can exist. And they even imagine, what kind of animals and what kind of things that can exist in that. And so there's a lot of research going on in that realm right now, to find those white dwarfs, and which they have found many of them, and many planets around them in that habitable zone. So that research is going on. So hopefully someday we'll find that twilight zone with some, animals and, things like that.
But, again, they're thinking in terms of life like ours that exists like us. But there could be life, which has a different requirement altogether to exist. It doesn't have to be like us.
Exactly. So it doesn't have to be oxygen. It doesn't have to be, the composition of the air that we have. Yes, absolutely, that is true. In fact, some of the microbial life can exist without oxygen. And in fact, they have a very strong suspicion now that on the Venus, which is a very hot planet surrounded with a tremendous amount of gas, okay, that may harbor a microbial life, because they found an element in the air of the Venus called phosphine. And that phosphine gas is only emitted by the microbial, life, or it can be just manufactured, in a factory. That's it. Those are the only two ways you can make the phosphine. So obviously there is no factories or anything on Venus. So the suspicion is that there is a microbial life that is, emitting that phosphine. So there is going to be a mission probably in future going to investigate that, So yeah, so you don't have to have the same environment, and it doesn't have to have a same composition and structure as to what we look like. It could be completely different,
What is NASA gung-ho about right now? What is it that NASA is most interested? What, like their biggest project?
Right now, I think mainly NASA wants to know how the Earth was formed and our solar system was formed. There's a lot of focus, and also if there is a life on Mars. There is no probably present life so far we haven't found, but there is a very strong evidence that there was a past life on Mars, because there were oceans on the Mars. There is a lot of evidence of the ocean flowing. Because some of the those rocks and sediments they have found, they can only exist if there was water. So we just sent a mission in July, another one to the Mars, which is going to reach in about 6 months, and that is going to try to find those. It goes to the particular area where there was an ocean flowing. So they're going to analyze. It's going to drill through some of those rocks and find the elements and see if there was some kind of a life in past. And also we are trying to prepare to land on Mars in future. And so this particular spacecraft has an instrument that will generate the oxygen, because you have to have oxygen for us to be able to survive. There's only so much you can take. But if you want to survive long term on the Mars, you have to generate some kind of oxygen. So we have an instrument, that is going to experiment with the generation of the oxygen on the Mars.
Is that the project you're working on?
Yes, right, exactly. I worked on that whole project, and now, of course, it's coming to an end. The spacecraft is already on the way to Mars. And another thing it has, which was never done before, it has a small helicopter that is going to fly. So that way we can cover a lot more area on the Mars.
Helicopter meaning once the spaceship
Small
lands there,
helicopter, yes. Yeah, exactly.
there will be a helicopter that will take
Right,
care of
exactly. And it will go, right, exactly. Just like a helicopter here, it will go around the, certain terrain of Mars and do the research and see if there's any interesting thing they can find, because such a huge planet, with a spacecraft, we can only go limited distance. So
which is the fastest spacecraft or ship that we have right now, and where have you sent it? Where is it right now?
okay, so the average speed that a spacecraft goes is about 38 to 40,000 miles an hour. Okay, in the space. Okay. Now, speaking of that, I can probably elaborate not only fastest, but if you want to know what is the oldest spacecraft that we have in space. Okay. So we had two spacecraft called Voyager 1 and 2 that were sent out in 1977.
Right.
So
we know about that one, yeah.
43
Where
years
is
ago.
it right now?
43 years ago. So they have right now crossed the boundary of the solar system into the outer space. Okay, both of them. So they are apart. One is heading north on the space, one is heading south on the space. So the sun has what is called the radiation, and it is emitting what is called a solar wind, which are the charged particles of plasma, and it forms a bubble in the space, and that bubble contains the entire solar system that as we know of right now. So once you cross that bubble, you are in the outer space. So what happens that bubble is called the heliosphere, and so the solar wind, their effect when you reach at the end of the bubble will diminish, and then the cosmic wind from the outside space collide with this solar wind, and eventually they will take over the cosmic wind. So right now those two spacecraft are in the region of the cosmic wind, and we detected that we are still getting signals from them, because there is a nuclear isotopes that is generating the electricity and sending the signal on us. So we are detecting those signals, and we detected that it crossed the heliopause, because that's where the effect of the solar wind diminished, and we detected that over here. So now we know that they are in completely outer space, out of solar system. And we will probably get signals for another 5 years from them. And it is supposed to be continuing forever in the space, and we won't know after that, because all the electricity will stop, working on it. And so we won't get any more signal. But those are the, two man-made objects that have gone. Is right now, one is about 14 billion miles and one is about 11 billion miles, from Earth.
Wow.
Yeah. So that's
so they will keep moving away from Earth. There's no plan to bring them back.
No, you cannot. That's it. Yeah, there is no fuel to bring them back, So, but that you don't. Yeah, unless you want to change the direction or velocity, you don't need any fuel. Once it starts in the space, it will keep on going forever, unless it is stopped by something, because there is no friction or resistance or anything, So it will just, according to Newton's law, it will just keep on going,
Yeah, there's nothing to pull it back.
Nothing to stop it or anything. Yeah, exactly. So, there are calculations that one will reach the nearest star in about 35,000 years, and another one will reach into another star called Barnard stars, which is the brightest star. If you look in the sky and look at the brightest star, that is called Barnard stars, it will reach in about 296,000 years to near that star, So those are the calculations,
We have to be born a few times over to
multiple times. Yeah, that's true. So those are some of those things, and they are traveling at roughly about 38 to 40,000 miles an hour, with the spacecraft, So you can have a higher speed, but the reason we don't have a higher speed is because what we want to do is we want to go to outer planets, we want to use the gravity of the in-between planets. Like if you want to go to Jupiter, we want to use the gravity of the Mars to increase the velocity without using the fuel, because we want to conserve the fuel as much as we can. So we have to slow down when we reach near Mars and use the gravity to kind of a slingshot, the spacecraft to increase the velocity. So that's why it's taking longer, and you cannot have a very high speed all the time, because, and then we have to slow down to study some of the planets and all that. So the speed is, it's not that high, because you have to always maneuver it to see what you want to do, whether you want to stop and take the photograph and take the, measurements and things like that, of the radiation of the magnetic fields and all that on those planets. So that's why the speed, but it can go right now up to 70, 80,000 miles an hour. Spacecraft can go double
So
the speed.
it does send back pictures and stuff like that, huh?
Yes. It sends, right now it's, sending the signals. It sent the picture of the entire solar system with the Earth being a dot. We have that picture that was sent by the Voyager. Yeah.
And that is not very far away. From there, if Earth looks like a dot,
it's a dot, right?
Yeah. So like
it's about,
really far in space, when you're really far in space, Earth you won't even see it. It won't even look like a dot.
Not only that, but you won't even see our galaxy.
Won't even see our galaxy, right?
Our galaxy will be like a dot. Yeah. You won't know whether it's our galaxy or some different galaxy,
Correct.
Because there are millions of galaxies, so they all look similar, like a dots. Yeah.
Wow.
So the distances are so vast, and it's just beyond our imagination, and that's only our universe.
No, when you hear this, even though you may know about it a little, you've heard it, you've read it, but when you think about it, it just expands the mind so much. You just feel like it's such a huge universe. And then, you just, most of the time we're so stuck in small things, in our lives. We're just stuck in a few people, a few things that are happening in one city, in someone's home, someone's family, someone's friendship. It's such a big thing. My reputation, my name, how many people know you? 500 people, 1,000, few thousand people know you, but that's nothing. No, even if the whole planet knew you, it would still mean nothing. Because, just look, your planet has no significance. It's just like one little dot somewhere.
Absolutely right. What we see, billions of people and millions of square miles of land, is just nothing when you go out in space. It's so small. Not only that, but our position in the space is not at all unique. It is a very common position. There's nothing unique. That's why there is a very strong suspicion that there are, other civilizations.
Civilization is probably higher, more
right.
intelligent.
In fact, recently there was an incident. I'm not sure whether people heard about it, but in 2017, there was an object that they detected in the space that was traveling at a very high speed. Usually, those objects, they look like asteroids, which are, continuously rotating around the sun. Those are the remnants of the solar system. There are millions of those asteroids between Mars and Jupiter. They're rotating around the sun, So first it was thought it was one of the asteroids. But then it was detected that it's not an asteroid because it didn't have an orbit. It was just going up and down and all around, So then they measured the speed, and it was like roughly about 200,000 miles an hour. So definitely it wasn't an object made over on the Earth, because we cannot achieve that kind of velocity, So there was a lot of interest in that object, that where did it come from? And eventually it went towards the outer space, and then when they tracked it, it was going towards one of those white dwarfs. So that's why there's a very strong suspicion that there may be an alien, spacecraft. And what was happening, the way it was structured, they took the photos and everything. So it looked like a rock, like a cigar-shaped rock. So they believe that what they did was, the civilization was so smart, they camouflage it. So inside that rock was a very advanced, spacecraft. So those are all theories.
No, meaning, is that assumption or?
Assumption, yeah.
Just
I mean, it was so far, you couldn't detect it, you cannot
correct.
chase it. It was so fast,
Yeah,
So,
yeah.
but so that was an assumption. So there are, signs, time to time that, tells us that, yeah, you are not alone, So,
Yeah. No, so if you, you know, I've been Googling stuff like that, and there are just so many stories on, strange events, incidents. People have had experiences. So we don't know how far it is true, but there's so many out there who claim to have had some encounters with people from other planets or people who they don't recognize as normal human beings. So, but we don't know how true that is. But I mean, if you say that, then it's obviously something that NASA knows is looking into. No, if you're saying it, then it is.
that is true. Yeah. I mean, so NASA and, the scientific community, they believe that, there is definitely alien life. It's just a matter of time. I was looking at some interviews of some of the prominent scientists, and they said that it will be like 2 to 3 decades before we will have a contact with an alien civilization, because it definitely exists. It's just a matter of us getting that technology, and a matter of they, developing the technology where two can come together, where we can have a contact. So they feel we are close, in making a contact. Now, just explain us from the spiritual point of view as to what are the thoughts as per our scriptures and our, saints and, all those.
No, life exists. Life exists in so many different places. And again, like I said, it's not necessary that once, do you remember you told me that human beings are almost blind? You remember you once said that we can see
Exactly.
very. Can you
Yeah.
can you expand on that again and tell, there are so many people who would be interested in knowing
Okay.
about the people with
So,
us.
so what we see a light is a part of what is called electromagnetic spectrum. Okay. So those are the waves, that we receive, from either sun or different objects, in the space. And that spectrum has a different frequencies. So there is a band of frequencies between zero point 0.4 to zero point 0.7 micron, which is like 400 micrometers. That's such a small, wavelength, to 700 micrometers. That is the only band we can see with a visual eye. There's a huge band beyond that, and it starts with like a cosmic rays, which is a very high frequency and high energy rays, and then there are X-rays, and then on the other side of our visible spectrum is the infrared, which is the heat waves, and beyond that there's a microwaves, and after that there's a radio waves. Now the radio waves are the one that has a long frequency, so that can travel. So right now, whatever the radio programs that we have been broadcasting for hundreds of years, maybe 100 years or so, they are in the space. So if there is an alien civilization that is intelligent enough to catch it, they can listen to our music or talk and everything that was done 50, 60, 100 years ago. So those are the radio waves. And then on the other side, as I say, cosmic waves and ultraviolet waves. So those spectrum are so large. So our capability of seeing is very, very small. So that's why we say that we are blind. However, we are intelligent. So we have detected the instrument to detect the ultraviolet light, infrared light, microwave, and things like that. So when we take the photograph sometimes of the planet, we cannot see everything with the visible telescope. We take the image, but it hides a lot of the features of the planet. So we use the ultraviolet, we use the infrared, and we use the X-rays to penetrate and get the different features. So when you combine all that images, you get such a clear, sharp image of, things,
Talking about, I just want to go back to when you talk about radio waves. So, uh, so you talk about space, right? And ether, that sound, whatever has been said, whatever words have been uttered, whatever thoughts have also been thought, they all exist in space. They just don't diminish.
Correct. Because those are
Correct?
vibrations,
Yeah, they're just vibrations.
Yeah.
They'll always remain, meaning they could have been uttered millions of years ago, but they're still there in space.
Yeah, the only difference is the sound vibration, they don't travel far. Whereas the electromagnetic radiation, they travel far. And the reason the radio, signals and television signals are far is because what we convert the sound and the image into the electromagnetic waves and we broadcast it. That's why it can travel so far. So that's the difference between sound and that. The sound has a limited range where it can travel, whereas the radio waves, and that's how we are receiving the signals, from the distant spacecraft. They're sending us a radio signal, and we have a big network of what is called a radio telescopes over here that catches those signals. Now, those Voyager spacecraft I was talking about so far away, their signal strength is so small that you need an extremely sensitive radio telescope, to receive that. And that's what is happening, they're receiving it.
The universe is within us. Can you comment? Whatever is out there in the universe, being the macrocosm, it exists within us. It exists, that I'm sure even science also says that, right? That an entire universe exists in a cell.
Correct.
Not in an atom, so.
We are part of universe, that's where we came from. Yeah.
The micro and the macro are, it's just the ratio differs, but otherwise, the ratio is the same, but whatever is out there in the universe exists within us in the same ratio.
Exactly. Those are, basic elements, that exist in the space, they are within us, it's the same as once, again, going into a little bit of spirituality, that our consciousness, that keeps us alive and keeps us thinking. Once that leaves us, we are just same as any space debris. There's no difference between us and a space debris.
True.
Right? Is that correct?
Absolutely.
Right.
Yeah. Any idea about, are we a result of the Big Bang theory that happened?
Okay, so here is the scientific theory. Okay, so about 13.5 billion years ago, whatever was existing, nobody knows that what was existing before that. There are several theories on that, but everything collapsed into a very, very, very small, element, or size, extremely small size. The whole universe collapsed into a very small size, and then it just exploded in a big bang. And that's where all the, galaxies and planets and stars and everything form. And eventually, according to scientists, again, they believe that some of those, planets, what happened that, there were small meteorites which were part of the planet. They landed on Earth with the DNA in it. And that's what created a human being. So that is the scientific theory, is that DNA came from outer space into the Earth.
Wherever it came from, it always existed. So it's just been rearranged, but there was never a time that we didn't exist. Am I right?
That is correct. Yeah, it always existed. It's just, it's either inhalate and again recreate, again inhalate and recreate, and that's what is happening. And that's what the scientists, some of them believe that, there existed before the Big Bang, there existed a universe, but again, it came to an end, everything has a life, I think, including the stars and planets and everything, So eventually everything comes to an end, and then again it recreates, So.
So everything that's tangible, it has its own lifespan, and then it is recreated. Again, we have someone asking us about God particle. Can you tell us a little about that?
Sure. Okay. So there was a particle that was believed to be existing, that gives all the weight to the matter. In other words, the weight of the protons and the neutrons in the atom is believed to have been given by this particle called God particle. So that was the term that was invented by those journalists. It was not invented by scientists, because they thought that it was something exotic. So the scientists, took upon themselves, they say, let's evaluate what exactly it is. So they went to this, what is called is a collider in Switzerland, and they bombarded again the atoms with the very high energy radiation. And they detected electrons, they detected protons, and then they detected some particles that they couldn't figure it out what it is. So this happened very recently. So they took those measurements of those particles, and right now it's being analyzed. And they believe that those are probably the God particle, but the scientists have named them as a Higgs boson particles, because it was a scientist called Higgs, who kind of was responsible, and there was another one was a boson. So it's called as a Higgs boson particle, And again, it is so exotic. That's why it was given a God particle name, is because it gives the mass and the weight to all, the protons and neutrons. So obviously it's a very important particle. So right now they have not put their hands on it, but they are very close in detecting those, because they have identified, those particles separate from the electrons and neutrons and everything, they have no relation to that. So there is a research going on, and hopefully in some near future we'll hear about it,
Yeah. So is there any more? Do we know any more about the nature of that particle?
It's just that it's a subatomic particle. That's all we know, because it can only be detected by very bombarding with very heavy radiation. You have to separate it from the atom, and it takes a lot of energy and all that. And it also takes a lot of very advanced scientific instrument to measure that. And one of those instruments was invented here in Santa Barbara in California, and it was sent out to Switzerland, to detect it. So those are some of the things that, right now being worked on, and there is a very high hope that those detectors that were invented over here, very high advanced technology, instrument never done before. So they will be able to detect those Higgs boson particle known as a God particle. And we can probably do more analysis and find out exactly, what it is,
If you have enjoyed the video, please click on the like, share, and subscribe button. Click on the bell button for notifications of new videos.